can record soon.
Yeah. Okay, please. Yeah. I think 0.998 is coming reflection. So that is fine because we are having resonance, right? So some losses will be there because
No,
substrate with
it's
that. Yeah.
yeah, it's still one, as we can see the last time. So you see,
Oh, it should be.
yeah, the reflection magnitude is still one. It's almost, and there's a metal surface. Can you click on the face? Let him see, please.
Can you again set the context to I think it should not reflect, right? That is the
No,
context.
no, it should reflect
Okay.
because it's a metal surface. There's a band gap.
Band gap. Okay.
Remember, I showed you that time.
Yes, yes,
Yeah,
yes.
First, let me show him the design first. Maybe
Yeah,
this is
yeah.
the design.
Okay, okay, okay. Got it, correct, correct. Got it, got it.
It has this is the patch, and
Okay.
this is the via, and this is the ground. So
Ground.
the
Okay.
substrate, I just hide it.
Okay, okay. I understood, understood. Okay,
Just hide
now
it.
what is expected is one, right?
it should be
Yeah,
less than one at
Less
least
than one.
because there's a. Remember, can you go to the linear? But you
like
see,
the
it doesn't make sense because it's like there's nothing there. 0.99 is the same thing as one.
Yeah,
Maybe
yeah.
if we have 0.89, that should be something. Even though, do you understand what I'm saying?
Yes,
My
yes.
professor was saying, doesn't make sense. It's a metal surface. Why are we having reflection manager of one, like as if it's a metal? Am I making sense?
Mm, uh, in principle, meta surface or anything if you are having reflector in the bottom, then you will get to that one in that is normal thing to do. I think what he is expecting is we need to these signals to be absorbed, right?
A little bit, yeah,
Little bit,
very
yeah.
small. Yeah,
Okay.
yeah, yeah.
Maybe can you okay, you have swept for 0 to 30. Okay. Mm,
Remember, you said that I should I should connect the VR to ground before the VR was only on the top. Remember? Yeah, you want
yeah,
to see the
yeah, 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 yeah.
current distribution, if you remember.
Yeah, yes, yes, yes.
Yeah. So should we show you current distribution? Maybe that's why. I don't know.
Actually, again, I recollect back that so it should absorb or suppress the some of the
Yeah,
uh,
little of it. Yes.
so that is yeah, if you keep a patch on top of this, you will not get back radiation. That's why. Okay.
You said you want to
Mm,
see the current distribution. Remember, I should connect the VR to the ground before the VR was only on top.
yes, yes, yes. So what
But
was the results before? Sorry, I.
almost the same thing like this. Yeah.
Mm,
So I connect it now to ground. You say you want to see the current distribution. The last time we spoke.
yeah, yeah, yeah. Can you go to simulation, please? Okay, boundary and all, it's fine, right? I don't know why it is coming like this. But what was the response in the paper?
Okay, the response in the paper, the paper, the reflection magnitude is like, but they did not do reflection. Sorry, the reflection phase. Should I
Okay.
show you the paper?
Yeah, yeah. Actually, I think a reflection phase only they have shown, right?
Yes,
Not the
yes, they did not do
magnitude. Yeah,
reflection. Yes, but
yeah,
they
yeah.
asked me. My professor said, okay, let's just see, yeah, the magnitude. You remember? Yeah, I showed you.
Yes,
Yes,
yes. Correct, correct, correct. Oh, okay.
you say you want to see the current distribution the other time. Should he show
Yeah,
you
yeah,
the?
yeah, yeah. We can see. Can you check the boundaries? I think you have PEC in the bottom, right? Really?
Yes.
Okay. Um, but anyway, if you put PVC, do not put PVC, it doesn't matter because you have a reflector in the bottom. Ground plane in the bottom. Hmm. Or can you change it to open, please? Once.
it.
No, don't do. No, no, no. You're going to cancel. Yeah.
Yeah, save us, save
So,
us. Yeah, save us, and then you can open another file.
Okay.
Maybe. Yeah, we can try that. And on the bottom one, the gray one is ground, right?
Yes.
Okay.
you don't want to check the current distribution for this one first of all?
No, we'll check. We'll check later. First, we will try this one. So what is the difference? Because if it is boundaries electrical, then it will be just giving the yeah.
It open.
So the green is ground and this one is a patch, right? Actually,
Yes, this is the patch. The
okay.
yellow is patch and
It's
gray is ground.
completely. It's the same as that of the ground plane size. Not right.
No. It's
Okay.
different.
Okay. One more thing. Like, did you try changing the patch size?
The patch size, yes. I played with this patch size, but I was still getting something.
Okay. Okay. Now, can you simulate now? Just once, one. Let us, compare the way we impinge on the patch. Then,
Oops, it's not going. They said the port mesh could not be extracted
Because it's open. I think so.
maybe
because
can you make it as open add space?
okay.
Is it working? Okay, it's working.
Yeah, it's loading. Let's see. Can you go to S11, please? The top one. Can you go to ports, please? Ports. No, there is a ports. Yeah. Zmax where it is? Okay, okay, fine. That is what we need. Yeah, yeah. Okay.
Yes. Can check the next two.
Yeah.
The next one.
Yeah, yes, no, yeah, yeah.
That still can wait a little bit.
No. That is a different mode actually. One is vertical, one is horizontal. And
Yes.
Zmin of two, Zmin only S22. But that I think because depending upon the number of modes that we set, based on that one, it will come.
I mean Z max is vertical and Z min is horizontal, right?
No. Zmax is the port one. Okay.
Yes.
Zmin is the port two. You have to put the bracket, whatever is there, that is the mode, vertical and
Okay.
horizontal.
Yes. I got it.
Because Lingatami, I don't know, you are very good in making electromagnetic very easy. What is the secret?
No. I'm not that great and all, but still, something I know, I just sharing with.
Oh my God. Yeah.
I'm sorry that it's
No
not
problem.
that
No problem,
So,
it's
Professor.
not that fast. I
Mufamba,
think it's supposed to be. I
your
think
computer is very fast. Why is it slow this time? It's not the office one?
No, because you have
this
added
this
the
is a
no,
this
no,
is
no,
the office. I think somebody is doing some simulation. I think so. Let me check.
no. I think because of the
Yeah.
open ad space, right? Oh, okay,
I have
Oh,
another
so,
student. I have another student doing simulation. So
okay.
oh, that's why. Okay.
this is a school server.
Mm.
Yeah. Click on linear. Let's see.
It's still coming. If you can wait.
No, no. You see, still very high.
Same thing. Mm.
Then if
Uh,
you check the current distribution, I don't know. No.
I think your distribution has not nothing to do.
Well, okay, that's what he suggested the other time. That's why.
No, no, no. What I was telling is like, how the whether it is yesterday last time we found it that the sorting pin was not there. So when we looked at the current distribution, so that was the motivation. But let's see.
Hmm. Hmm.
Professor, I will invite you for some lecture, okay, on the reflection in surface, so that it will be helpful for others to, you know, many people have misconception. So
Really? Thank you so much.
yeah, maybe we can
Thank
have one session, maybe two or
Yeah,
three,
sure.
uh,
Exactly.
and then tell them that okay, this is how it works. So
Yes, exactly. Exactly.
Mufwamba. Well,
Yes.
when you are, Dr. Lingisami,
yes, yes, yes. Yeah.
sorry, because he's doing PhD, he might not need to, he might just say Fabrice because so people will not start calling him. He's also doing research. It's not easy. Oh my God. Thank you very much, Dr. Lingisami.
Yeah.
Thank you.
I think it's done. Story is that people are using the server is quite huge. I don't
This is
know
the
why
first
it's
time I'm seeing your computer is not fast. Hmm.
no, I told you that I
People
showed
are
you that
using. That's
yeah,
why I know.
look, there is I don't know what time. Do you
I think.
see the
Yeah.
CPU is 100% in
Oh
use
my God.
Yeah.
and students, yeah, some student doing simulation as well.
I think yeah, results are almost visible because it is same thing. Maybe the
Maybe you can stop it.
yeah, yeah.
No, no, don't stop
So
it.
so
No.
one
It's
question.
post processing. Don't stop it. It's post
Yeah, yeah.
processing.
So one
It's finished.
question, only one question. Like,
Hmm.
so did we try the sweeping the patch size and then see any results? Like which frequency it got, dip or suppression?
Yeah, yesterday I tried to sweep the patch size
Okay.
and yeah, but I'm still having the same magnitude. So what you want for him, you want magnitude to be for the mean supposed to be, for example, 0.8 or 0.7, something like that.
Or 0.88 or so, at least just to show that there's an absorption a little bit because there's a metal surface there. Just to yeah.
Okay.
Let's see, you see, for example, this.
Okay.
You see, for example, you want to be something like less than this.
Mm, but I don't know what the paper they have shown the phase value that is exactly matching, right? Whatever we are
Yes,
getting.
matching. Yes, yes.
Then
But when I
maybe
showed, they don't say, oh,
maybe see one thing could be possible is, for example, one as a one cell it is reflecting. Maybe on the whole, for example, maybe the array of EBGs, so it may respond because that is my opinion. But let's see. You have put the same substrate size, everything is same, right? Why? Because we are getting the phase result as exactly same, right?
yeah, yes, face is
Yes.
same.
Yeah, because maybe uh, the whole structure, right? For example, you will create a array of EBG structures, then you place it in bottom of the what do you call this, patch, then we can try once. I think so. If we get the same result, then it's fine, right? It's working fine. That's all. So I think, if you're having the ground plane and the bottom, definitely you will get the complete reflection. So can we see the current
But you
distortion,
see,
please?
he
Yeah,
he has shown you a different structure with which he simulated. I mean, Professor Mufwamba,
yeah, yeah,
before
yeah, yeah,
5 rates. But you can see that there's a loss. Yeah,
yeah,
he's
yeah.
having 0.7, 0.5.
Correct, correct, correct. The thing
Yeah,
is,
so why is this one not giving maybe 0.8 or something? Because remember, I told you, for some months now, they were
no, no, no.
arguing.
That structure itself different, right? But did
Yeah,
you
I know.
connect the ground plane with that
Yeah, the ground plane is connected.
through strip or something like that?
Yes.
I don't know
Um,
what's happening.
just trying to open this.
Okay,
This is the same structure.
okay.
Maybe I'm going to run it.
Why are you running this one? Which one is this?
This is that we did last day. So again, okay, I think I just a couple of um just you
Linear.
see what we
Linear.
have got.
No, no, that is almost 0 dB. Yeah, that's
The
okay.
same thing.
Yeah, yeah. Okay. The one thing could be, can you go to the previous structure, please? The previous one. Yeah, can you go to the 2D results? 2D, 3D results. Bottom. No, no, on the bottom.
Down,
Left,
down,
left,
down.
down.
Yeah, yeah, yeah.
Surface current, and then see how the
Surface
flow
one.
is. Yeah. Or a field also we can check. So maybe which frequency we want. There was a
And
dip, right? Means
yeah, it's
that's what
between
I'm saying.
11 and 17. Yeah.
Okay, that the
This
12.5
one?
is fine. 12.5 is
12.5.
fine. Yeah, yeah. Yeah, can you animate that?
Okay.
Yeah. Can you zoom, please? Or I know E field. E field. Can you go to E field? Can you give me control, please?
Okay.
I'll
Please.
give you. Okay. This view is good, I think. Okay. Um, it is coming down. There is a plane wave is coming, and then simply getting reflected. So that is structure itself like that. So I think maybe
So the current is going down, right? Through the VR. To
yeah,
the foot.
going down and then reflecting back, right? See, it is sitting there and then reflecting back.
Um,
So that's how the structure nature is. So 1 minute, let me check.
Mm.
Can you see?
Mm.
Just reflecting back only. So the structure itself like that. What I believe is like, what I believe is maybe that the array structure, no, on the whole, okay, that will
Mhm.
give me this, this reflection as zero or absorption like that. I think so, because if you
Okay,
yeah,
continue. Speak. Continue speaking. Sorry.
yeah, yeah. So in reflector, if see the meta surface, no, the same thing, same meta surface could be used for the reflection as well as the absorption. But if you don't have that, it's just a plain thing. But I don't know. But mm, it's just
Because
looking.
I was arguing with this professor and saying, oh, because there's a sorry, there's a PC on the floor and it's infinite on both sides. He said, doesn't make sense. Remember, I told you a long time ago. He said, if you have electric transmission, or sorry, a signal, you have a metal surface. What is the essence of the metal surface? You see the reflection phase, there's the band gap there. At least there should be some absorption, no matter what, even if. So they will argue. I just had to, they said it doesn't make sense. I mean, you don't know what to. Remember, that's why I came to ask you. That's why I was forced to come and meet you. Mm.
Yes.
Which it makes sense because you have an EBG, at least maybe if 0. Well, it says 0.99, it's just it's like one.
Yes. Yes. Yes.
Okay, this is the reflection that is happening. Yeah, okay. This is
Yeah.
green. Mm,
It completely reflecting. That is the.
mm. Okay, can the fabrics, can you show your own structure? Let's put and see whether there's
Yeah. Yeah.
loss.
Yeah. Yeah.
Dr. Fabrics,
Yes.
please. Put your structure. Let's do the same thing like this and see whether there will be some loss. Your own structure, please. That one that has 0.5 or 7 or 8. Your own structure.
Wait. Maybe I need to simulate again.
No, your own structure. You had the result already.
Yeah, but
The one that the one you showed that has 0.8, or remember? Your own structure, not my own.
that I show you what?
That you showed that has 0.5, just to
Yeah,
show that.
I think I
Remember?
need to simulate it again. I've made some modifications. I made
Huh?
some modification. I play with something on it. Yeah. I can do it again. I will just remove this.
Your own, not my own.
Yes, understand. Yeah, I know.
What is my own you're doing now? Or this?
You mean you are saying my work?
Yes, your work,
Okay.
your own work
Let's
that you. So
see.
let's see, do the video like how we did on my own. Your own work that you did that has 0.8. Do you understand?
This
Or
one?
0. Yeah, yes. So put the video. Let's see how it's reflecting. Yes, good. Put the video, the electric surface current. Yeah, yeah, good. No
Uh,
surface current.
so I will just
You, you don't have surface current here.
No.
yeah.
Why?
Can you open this
I did
paper?
not define. I
Can
did.
you please open this one? This paper?
This one?
Yeah, this paper. No, no, no. I have sent you some paper in
Okay.
the chat, in the chat.
Okay. Do you see it?
No, we can't see anything.
Really?
Yeah,
Mm.
we can see only the simulation going on. Simulation 2.
Oh, sorry. I think I showed you the screen.
Yeah, no, good.
Yeah, can you go to the previous page?
Previous, please.
Yeah. Here can you see? It's 0 dB only. Band gap. That's what they call it as band gap. reflection coefficient is 0 dB. Can you go up, please, slightly?
Here, I mean this.
Yeah, 1 minute. I think I can also control, right? 1 minute.
Okay.
See the bang up. Yeah.
Yeah, can you see here? It is 100%. Reflector power is 100%.
Mm-hmm.
Yeah, then that is the nature, right? So maybe that the array of structure is behaving like that. But I think maybe this is also a bang up. This paper is based on bang up only. So
Okay.
yeah, I think you can show him this paper. Maybe you can read and then you can just take a notes and then show him. Okay, professor, can you what do you?
I showed him some paper from this thing. He said he has been. I have old and younger prof. They say, well, we're not asking for it has to be 0. At least there should be some little absorption because there is a band gap there or meta surface, unless it's not a meta surface. That the design or I don't know. Why should it be 0.99? I said there's a dip. I showed them there's a small dip there, and they said what they call it. The dip is 0.99, the same thing as one. There's nothing happening there. If it's 0.89 or 0.9 or 0.8 or something.
Okay.
I've showed it's more than a month. They said then you don't know what is a meta surface. Then why is there reflection phase between 11 and 17 gigahertz at zero? I should give a good explanation as a researcher. That's what I can't understand to give again.
Okay. Okay. Shall I do one thing? I will spend some time on that because maybe I will just spend some time and then shall I get back to you? Because what is the rationale behind this? This easily reach results and other thing. Yeah.
Well, this one on the left is reflection is 100%.
Yes.
Oh, zero and what is why is it 100.0? Is that 1, 9, 8, and the rest, right?
Yeah. That is what they call it as band gap.
I know, yeah. Hold on. Yeah. That is it. Okay, the reflection coefficient.
Yeah.
And you can, but see this one here at zero.
0 dB. Yes. 0 dB means one.
Yeah. Can you come down small, please?
Yeah. Yeah. This is this is T band gap and this is TM band gap. The wave impinged on this one is vertically. Here it is horizontally.
Yeah, yeah. There's a PEC on the ground.
Yes, yes, yes. Let us see the. You can see here complete band gap is 0 dB only. They are saying. Can you see here?
Mm. Dr. Mfomba.
Yes, sir.
Yeah, when you can show that your own that had loss. Let's see how the thing's reflecting or this. Do you understand?
Can you see
Which
here?
one?
Can you see here?
Mm.
So can you see
Yes,
here?
sir.
There is a
Mine is not reflected array. Mine is areas. It has a active element on it. So
you can see here.
Oh,
it,
okay.
Can you see
yeah.
here? Can you see here? And there is a antenna which is backed by this EBG. So
Mm-hmm.
you will, for example, with PEC you are getting. You can see here. Can you see here? The reflection is S11 is here. With the EBG, the reflection is being reduced here. Can you see here?
Yeah, yes. Mm-hmm.
But it is a whole array, but not the single element.
Yeah, which is a unit cell. Yeah,
Yeah, this is what I was telling from the beginning.
this is what I tried to explain. It still did not make sense to them.
No, you
I
can
don't.
just tell them maybe you could show this paper and then explain him. Can you see here? So this is the patch. On backside, you have this. Do you remember this unit cell? I think not this unit cell. This unit cell. This unit cell they having on the top of the patch is there. Behind that it is there. Pattern is the gain is improving because the reflection is getting reduced. That's why the gain is improving. That's what they are showing. Okay. With no EBG, with EBG, just reducing, right? This is to show like coupling reduction.
Yes, which is normal.
Yeah. I think you can take this paper and then show him.
I can show you one paper I have shown them before, or
Okay,
something
okay.
like this, and they say
Maybe
no.
you can just explore this. Can you please? I will also read, whenever I find time. Then if I get something, I will just let you know.
I've
Because
shown them a paper almost like this about that because, as I said, remember when we started, I said it's because it's a one unit cell, it's
hmm,
infinite on both X and Y, and it's a
yeah,
metal under. I explained something like that. Remember?
yes,
They,
yes, yes,
they
yes.
say oh, it's finite or this thing. They're
Okay,
saying is there's one physics word they use. I've forgotten
okay, okay, okay.
that if you have the metal surface on top and there's a dielectric under, there should be some absorption or something.
No, no, no. Actually, the meta surface and these two are,
And the dielectric and I
yeah,
can't
yeah,
remember.
yeah.
The substrate, sorry, yeah.
Yes, yes.
It should be small element of absorption, a little bit, very small, minimal, depending on the
Correct, correct,
material.
correct.
So 0.99 is the same thing like 1.
Yeah,
If
yeah,
it
yeah.
is
That is,
0.89,
here also they clearly show, right? This is the
mm,
EPG structure they are trying to propose. But the thing is, the reflection coefficient you can see 100%, 0 dB.
mm,
This is the same thing, only they are putting, placing behind the patch.
y-
So,
yes, but they show the reflection face. Let's see the face.
yeah.
Let's see the face. You have a face there, please?
No, no, no. Face is
Okay,
not
no
there.
face. Ah,
That is the problem. We
yeah,
have
so
amplitude here, no face. There, face is there, no amplitude.
so they are using that face now to show that, oh, look at in this place, this is what is happening. They
Here
should
is
be
the
some
face.
loss.
Here is the face. Can you see here?
Yeah,
Can you see here? But maybe we can try this and then show him. So the same paper, it has both face and this one. If you could reproduce, then yeah, that makes sense, right?
I've showed him paper like this. They don't want to accept.
No, no, no.
I've
What I'm saying
tried.
is, you just, you can just reproduce this result and then say, see, the simulation is not a problem. That the inherent nature of that cell itself like that. It is my opinion, but
They said as a researcher, you have to have scientific reason, scientific.
mm.
Well, my brother, I'm tired. It's
Okay,
just
okay.
I'm tired.
Okay, sorry for that. And maybe I will just check once, and then if I come to, sorry for that. Sorry. If I come to know something, some key pointers, I will just send you by mail, or I can send you WhatsApp, and then we can discuss. Is it fine with you? Le-
You're a busy person. I can't disturb you. You have tried very well, even giving me your time. All this is it's more than how many months now? I can't even get.
No, 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 no. I will just check. It is a challenge for me because maybe my understanding is different, or it's that is the fundamental thing. So physics behind that, I will just
Yeah,
check.
that's the word they say. Physics behind. Why is it?
Yeah, yeah,
At
yeah,
least
yeah.
it should be 0.8.
Correct. So when it is, a unit cell, it is giving 100% reflection. But when in the moment we arrange it in an array, EBG array, then it is giving the
That is the result. That is what I told them that if it's an array, it will change or something. They said no. You need actually there was one other person like what Mufwamba did, like a moderator. He looked at it and said, "Oh, you have."
yes,
I share that paper with you, right? I
yes,
showed you the comments he made. Remember
correct,
some
correct.
months ago. Yeah, he said your EBG because he's also a meta surface engineer, or he does meta surface. He does it for UK defense. He said I've been doing meta surface for years. So
Okay, okay.
you can't confuse me here.
Yeah, yeah.
Ah,
So one thing, maybe sorry for that. Maybe I have to join another call in 7 minutes. So before that,
okay,
I
okay,
should
okay.
have
I'll have to like.
breakfast.
Then finally, Mufamba did something, and he said when he changed the dielectric, the thing gave a loss. Mufamba,
Oh,
can you come in now,
yeah.
Dr. Mufamba, Fabrice?
Yes, sir.
Yeah, you said.
Um,
Uh-huh.
maybe I need to, sorry, I need to run it again. So that's
Oh
what I
no,
was.
no, he doesn't have time. You have the result. That's why I said just create the folder that day. You have the result. You don't need to run it again because he has a meeting in 7 minutes.
Uh,
You have the
I think
result now.
I whipped out that result. So it's not going to take long. Just 2 seconds.
Because somebody else is using your system.
Yeah. Just
Dr. Mufamba, what do you have to say? Fabrice, what do you have to say about all this?
um actually I think uh I'm not doing research on band gap. So it's something beyond my knowledge. But I think professor has give some good insight on this.
Yeah, I know.
Um
I'm not arguing, it, but I told you my own basis, and when I tell them, I
um you mean to tell to your professor?
my professors, two or three of them. I've told them. They say it doesn't make sense. It doesn't. No, 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 no. I'm tired. I'm tired.
I think it's supposed
Yeah.
to make sense because the band gap is maybe they have ideas that reflected array unit cell is operating same way of band gap.
Yes.
Maybe this is what they think. Maybe.
Yeah.
Um,
Yeah.
I really
Sorry to disturb. So can you continue? So because I have to have breakfast and then join the call. Sorry for that. Is it fine? Yes.
sure, no problem.
Okay. Okay. So thank you so much. But my friend, it is good challenge for me. But I will just try to check.
Okay,
Mm,
finally, yeah. Before you go in 1 minute, I said he did. I'm surprised. Okay, the result has been removed. He checked different dielectric, and he said when he increased the dielectric, because the one we used was Rogers 2.2, Rogers 5880.
okay.
Increased it to about 6. The the reflection was reducing to about 0.8.
No, no. Can I say again? Like you were saying that he changed the electric and also the thickness.
No, those only the dielectric
I can
Mm.
parameter.
share on the WhatsApp group so you can see.
Yeah, yeah, yeah. The thing is, see, the resonant frequency keeps on changing, right? As because of
Not the
because.
resonance, the dip. It was the reflection coefficient
Yeah,
reduced.
yeah, yeah. But that structure, maybe it is resonating on that frequency. So, yeah. Okay, okay. Yeah, it is come. It has come, right? Really.
Linear.
Yeah, it's
You
almost
see?
Can you
come.
go to mode one?
Mode one.
Yeah, the first one is Z max of one.
Yeah. It- I used to say Z2.
That
This
is
one, for
also
example,
coming same thing, right?
this one. If, for example,
Yes.
if we read it from here or from here, but it's shifting. It's shifting when I change the dielectric. It's really shifting. You see, the mean is going to 0.7 and the max is 1.
Mm.
For
But
example,
it's shifting. But it's
if I
shifting the resonance frequency.
yeah, it shift the resonant frequency.
Oh, that
Yeah,
means
yeah. That
that's
is
not
that is obvious, right? Because if we change the electric, that it should be shift the resonant frequency. That is obvious.
Yeah, but actually it gives
No, no,
0.7,
it
which
is also one of the nature, like, for example, you remember, see, you are designing for some 10 gigahertz, right? But it is, resonating at 30, okay? But the thickness of the substrate for 30, if you compare in lambda, it is huge, right? 3 times, right?
yes.
Okay, then even if you even you can try this same thing. Your the previous one, right, where it is resonating at exactly 12, right? If you increase that thickness to 3 times, you will get the dip 0.75 because the substrate loss will be increasing, right?
Okay. So
Yeah, that is
what do you think about this? Is it this good?
no. This is not a unit cell behavior. It's a substrate behavior because your substrate size is same, but at 30 gigahertz it is huge, right? For example, let's say 1 mm. Okay, 1 mm is almost 1 lambda, right?
Yes.
Yeah, that also causes the losses, right?
Yes.
Yeah. Okay. Sorry to interrupt.
Okay, thank you
So
very much. Thank
yeah.
you very much.
Say
Okay,
let us
bye bye.
meet again.
Okay,
No problem. Yeah.
okay,
Okay.
okay.
Welcome.
Thank you very much. God bless
Yeah.
you. Have a great
Thank you
day.
so. Yeah. Thank you
Okay,
so
Thank
much.
you. Bye bye.
bye bye.
Yeah.